through it, and I'm with the group assigned to cover Cassandra. So I just kind of want to go over, its architecture and some limitations that the database has. So first, starting off, I got most of my information from Cassandra, the Definitive Guide, which is released by O'Reilly. So they release a lot of tech-related books. I've used a book for Python from them before, so highly recommend. I got a free download from datastacks.com. So if you wanted to learn more about Cassandra in pretty in-depth detail, I would definitely recommend that source. But anyways, if I were to describe Cassandra in 50 words, this is how I would do it. So Apache Cassandra is an open source, distributed, decentralized, elastically scalable, highly available, fault-tolerant, tunably consistent, row-oriented database. And now that has a lot of words in it, right? But we're going to break that down into each individual part, which is kind of why I highlighted it to begin with. And so, Cassandra originally got its birth from Amazon's Dynamo and Google's Bigtable, and it kind of just came together. And Facebook was the first creator of it, and then now it's an open source platform. So like I said, we're going to kind of dive into, what actually Cassandra is. So the first thing that comes to mind is distributed, so which basically means that it's capable of running on many machines. So this is kind of the reason why Cassandra and then other NoSQL databases were created in the first place. Relational databases have large problems when it comes to scalability, and so this is something that Cassandra is able to use to scale properly. And so basically what it does is it optimizes performance across machines and data centers, and it's decentralized. And it uses this gossip protocol. And so now this decentralized, pretty similar to distributed. Basically, it operates on a peer-to-peer network, so it's able to utilize like things such as the cloud. And so when you're looking at decentralized, this is also pretty much the same thing as server symmetry. And so what Cassandra does is it doesn't have a master-slave relationship where like a particular node controls other nodes. It actually has like I said, decentralized relationship. And what that means is every single node within the system is the same. The problem with the master-slave or the primary-second node orientation is that if a primary node or a master node were to fail, then a lot of other nodes within the system would fail. So it has failure problems. But with Cassandra, because it's decentralized, there's not a single point of failure within the system if one node were to go out. Now moving on to elastically scalable. So there's just a few things you can do, with your database, when you need more capacity, when it's kind of at its limits. So the first thing you can do is what's referred to as vertical scalability. So this is like adding more capacity or memory to the existing machines. Or you can horizontally scale, which means you're adding more machines that have access to all or some of the data so that no one machine bears the burden of serving requests. This is in a way like a network, and so this elastically scalable means that is referring to horizontal scalability that I just mentioned, where there's no disruption from, adding or removing machines. This is the concept of scalability. In relational databases, this may not always be possible. So there's not necessarily going to be disruption when you add or remove to machines to a network. And this could be a very big benefit for Cassandra because a lot of times, you're adding a lot of machines, to a network because it changes over time. The next thing I wanted to point out is its high availability and fault tolerant. So the high availability is just kind of referring to its ability to fulfill requests. And then fault tolerant, I kind of talked about it earlier with it being a decentralized and distributed system, because no one node, because they're all the same. Therefore, if one node were to fail, then that means the whole system would not fail. So that's kind of what I'm referring to there. And so there can be many types of failures, from hardware components to network disruption. But because, what Cassandra does, it's not necessarily, a problem as compared to other databases. Next, tunable consistency. And so consistently kind of refers to this idea that when you read something from the system, it always returns the most recently written value. And so there's different levels to this. In most data or a lot of databases, this is a pretty big problem, and I'll get into that in just a little bit with the CAP theorem. But there's 3 types of consistencies. The very first one is called strict consistency. So this is a system where there's almost like a global clock that is capable of time stamping all the operations, regardless of location or the number of users requesting within a network. And so it's basically always going to return the most recently written value. And then you have casual consistency, which is a step below, where you determine the cause of the events to create the consistency in their order. And so writes that are related, they are then read in order. But if 2 reads are unrelated, then the writes can be read from that same field at the same time. And then there's eventual consistency, which basically means when you update a system, it'll eventually be consistent, but there may be some time delay. And the thing is with a lot of databases, a lot of administrators, prefer to have this strict consistency. But what Cassandra lets you do is kind of determine the level of consistency that you require with the level of availability. And there's this thing called CAP theorem where you can't have all 3. There's consistency, availability, and partition tolerant. So like I said, consistency, this referring to the idea that you will always read the same value for the same query. And then availability, all database clients will always be able to read and write data. And then the third, partition tolerance, the database can be split into multiple machines. And so you can only have 2. So that's kind of the problem. And so on the right, I have a diagram which kind of explains, which databases pick which of the 2 of the 3. And so for Cassandra, it tends to choose the available and partition tolerant so that every machine's always able to access the database. And eventually the data within the database will be consistent if, people are writing stuff to the database at the same time. So now going back, one other aspect of Cassandra that's highly misunderstood is this row-oriented concept. And so it basically the way that the data model works within the system is the partitioned row store. So data is stored in sparse, multi-dimensional hash tables. So kind of a different concept from the relational data model, but it's something that Cassandra uses to promote the high availability that when we look back at the CAP theorem, that's how it's able to do it. And so a problem with these row-oriented type of data models is that sometimes it can be difficult to execute complex queries, which is why Cassandra utilized some of the SQL and kind of wrote their own language where it's Cassandra query language. And then finally, the last point I want to make is that Cassandra is a high-performance database. So it was basically designed for the use on multiprocessor, multi-core machines in multiple data centers. So if you were to use Cassandra, these are the things you'd want to use it for. First of all, it needs to be a large deployment that has many geographical locations in which you're conducting a large amount of analysis on many different environments. So given the complex nature of the networks that large companies face, Cassandra could be a suitable option for them. For us, it doesn't really make sense to utilize Cassandra when we're only utilizing at MySQL on our own laptops. But if you were to be involved with an organization such as Facebook, Google, or something of that nature where their operations are global, and they had many different machines running on many different data centers, then it would make sense to where you need that scalability, and that's where something like Cassandra comes in and offers that.
I'm Dylan Wolfson, and I'm going to be going over some of the limitations of using Cassandra. All limitations of Cassandra ultimately stem from the CAP theorem. Cassandra was built with availability and partition tolerance in mind, but that came at the expense of consistency. And by giving up all of that consistency, the limitations of Cassandra naturally stem from whatever you would need to be consistent with. Which means things like transactions are going to be Cassandra's Achilles heel. While Cassandra can technically handle transactions, it's still too inconsistent to make use of in any professional setting. And in addition, there's also much better and more effective alternatives that you can use instead of Cassandra. And that struggle with transactions is also a pretty safe assumption to make for pretty much any NoSQL language. It's just because of how they function and how they operate with the different queries, the transactions are going to be a struggle. The second limitation is going to be a lot of things like deleting. Cassandra deletes data using tombstones, which are essentially tags telling the system to ignore a piece of data during a read. And trying to pull data from a primary key ends up returning not just that up-to-date piece of data itself, but all of the dead tombstone data that was also associated with that primary key that you searched. So the limitation comes in where if you have a lot of deletes in one database, your sheer storage size that you need is going to expand dramatically. And the same is also true for any system that has a heavy amount of updates, because when updating in Cassandra kind of suffers from a similar tag system, where if you want to change a piece of data, Cassandra won't edit the original entry, it'll make an entirely new entry with the updated data, and it tracks which one is which using like an age system, where the youngest piece of data associated with a primary key is the most up to date. And lastly is reading without a primary key. It's kind of a rare situation, but if you're using Cassandra and you try to read without one, you're going to have a logistical nightmare on your hands, because without a primary key, Cassandra has to scan through every single node to find that piece of data that you're searching for. And if the network latency is a little too high, it'll just give up on the request altogether. But ultimately, all of its limitations stem from things that require high consistency, because it was made to handle a ton of write operations and track them over time. So any application that could essentially be boiled down to a log of some kind is where Cassandra is going to really shine. Editing the same piece of data over and over is kind of the total opposite of what Cassandra was meant to do. So it would stand to reason that Cassandra is going to struggle in the editing department, no matter what that entails. It's just changing a piece of data that you already have stored is going to be weird.
Hello everyone, today I'm going to talk to you about Cassandra in the industry. And let's start with uses Cassandra. And here's a list of some companies that we know that use Cassandra. But there's thousands of other companies that use Cassandra. And if we look at these companies, we will see that these are kind of companies which has databases of petabytes of user data. And they have very active and very large databases. And even though these are like super big companies, there's still a lot of startups and smaller companies that use Cassandra as well. And today I would like to focus on Netflix, because they use 95% of their whole user data with Cassandra. They stored in Cassandra. And Netflix announced in their developer blog that use Cassandra for its scalability and lack of single points of failure, and for cross-regional deployments. A fun fact about this is how Netflix brought House of Cards TV show back in the days. This was very big news, because this was the first TV program that was sold without it having a proven success. So Netflix used their user data to understand what the users would like to see, and they bought House of Cards with the algorithms they by the user with the user data that they got from their database in Cassandra, and that brought them a huge success. And I will talk about how Netflix implemented Cassandra in a bit, but right now I want to talk about like a little bit of the background. So in the past, Netflix was using Oracle databases when they were still in the DVD business, and one day their Oracle database went down for 48 hours, even though it wasn't Oracle's fault. And this showed the fundamental flaw in the shared database architecture. This happened when there was DVDs. A lot of people got their DVDs a couple of days late, so it wasn't really much of a big problem. But if that happened today, that would be a very big issue for Netflix. So soon after, Netflix realized they don't want to focus on creating their own data centers. So they went onto the cloud with AWS and they tried some cloud databases. And they realized that Cassandra was tailored for Netflix. The greatest reason for this was that Cassandra was multi-directional, multi-data center replication storing. And Netflix uses 95% of their data storing in Cassandra, as I said, and then the rest 5% is made up of the financial information of the customers, and they can't be transferred to Cassandra, even though Netflix is trying that right now. So they try to make their database full on Cassandra, but there's some lawful regulations on that. Let me show you this map about how their system works. So the arrows in here, they show the multi-directional replication that is built into Cassandra, and there are multiple data centers. So what this means is that like if any of these data centers stop working, or let's say there's a lot of traffic going into one of them, the traffic can be redirected to the other data centers, and the customers would have no problem in their experience. So that's what Netflix is trying to do, while they are constantly replicating all their data among these data centers. So another similar example to the House of Cards would be Facebook's Instagram fraud detection. So for Facebook, the only use of Cassandra is Instagram right now, and in the past they were using it in their inbox searches. So the replicating of data among different servers helps Facebook to identify scam and fraud. And previous to Cassandra, Instagram was using Redis, but the architecture of Cassandra fit Instagram so much better that there was a 75% immediate cost reduction when they started using Cassandra. Fun fact, one of the reasons for that is that Redis was storing data in memory, and that was increasing the costs, and Cassandra is storing in disks, I believe. And I want to give some small information about the installation of Cassandra. Cassandra on Linux servers runs on a wide array of Linux distributions, and a few of them are Ubuntu, CentOS, Red Hat, and Amazon Linux, AMIs, Debian versions 8 and 9. And these are not the ones that you see in the lists. These are not all of the distributions there are that run Cassandra. There's a lot more other versions and Linux distributions which can run Cassandra. Can I try it myself? Yes, you can. Cassandra requires you to have a Java 8 JDK, and if you're on Windows, you also need Python 2.7, and if you're on macOS, you also need Python, but in macOS, Python comes pre-installed, so you don't have to do anything. And for Windows, you will have to check your environmental variables and add Java into that, and Python as well.
Yeah, hi everyone. So now we are going to see the syntax and basic usage of the Cassandra query language. So let's assume we have installed our Cassandra on Linux environment, which is not any different from what we are used to. So first of all, we are going to see how we write comment in Cassandra. It's not far different from Java programming, because we may use double dashes, or sometimes we may use double slashes, or we may also use slash with star with asterisk to show like multiple to comment out multiple lines. Also, in Cassandra query language, we can create a table in a very same way we do it in MySQL. We just say like create table monkey maybe species. It's an example. Then you put species, maybe it's a var character. Then you put maybe common name, common name. Maybe it's a text. Average size. But what is more interesting in Cassandra, when you close the parentheses, you can also add a comment. You can say with comment, which is equal, maybe important biological records. So it's more of the same with MySQL, but something which is more interesting that we can add some comments on Cassandra query language. Also, I can show you how to do a selection in this language. So basically, it's the same to MySQL. You just say like select maybe from monkey's piece, right? Then the table is going to pop up. But there are multiple rules that govern selection in Cassandra query language, and I'm going to go through some of those. Yeah, the first rule, you have to use all partition key columns only with equal operator. You should ask yourself, like, what do I mean? So I think you can see like this table. So if you want maybe to select, maybe employee first name, like you are going to do selection based on these two partition keys, and my partition keys are already colored: employee ID and employee salary. These are my partition keys, which may be considered as primary keys in MySQL. So you have to make sure you use equal operator while selecting them. The second law is that you can use the clustering column in the same order as it is defined in table. So you can skip the sequence of cluster column. So let's assume you want to select the first name of employee. What I mean is this. Maybe you want to select the employee first name called like Rakesh. Select from employee. Select from employee where employee ID is equal to maybe, is equal to 1001. It's an example. And employee salary is equal to 100. It's an example, 100. Then and employee first name is equal to maybe Rakesh. So what I meant is that you shouldn't skip partition keys, which are employee ID and employee salary. Yeah. So if you want to select maybe employee first name or employee um, um, department number, you must make sure you select first employee ID and employee salary because they are my partition keys. I think it does make sense. Also, you can't use equal operator on only non-primary keys column without partition column. What I meant is that you can't say like uh, my employee first name. Let's assume you want to select uh, Rakesh from this table. You can select her. You can select him if you didn't use equal operator on employee or employee salary. So you are not allowed to use the equal operator on these two people. Yeah. Um, the the other rule maybe that I can point out is that um, yeah, also we cannot use equal, we cannot use equal, equal or equal, I mean, we cannot use equal or more or equal, more or equal or less, less or equal operators on our partition keys. And remember, my partition keys are now on my primary keys, which are employee ID and employee salary. So we shouldn't ever use equal or more equal or less equal operators on these partition keys. So these are the basic rules for selections, for selection in Cassandra query language. Also, we are going to see how to alter like the table. Now you are done with creating your table. Now the next step is going to alter. Let's assume you want to alter something. So it's not any different from the way we do it in MySQL. You just write alter, alter table, maybe monkey's piece, monkey's piece. It's an example. Then add maybe gravesite, which is var character. So basically, if you have created the table monkey species, now you can add another element of gravesite, which is a var character if you want to. So alter table is just make sure like alter table is not any different from MySQL. Also, we can use drop table. Drop table works in the same way my SQL drops table. So basically, you write drop table if exist. I remember because if the table doesn't exist, it's going to throw an error. But if you write if it exists, it's not going to throw an error because of that statement. Then you add the table name. So if you have a specific table name in mind, then you add it up there to drop it. Another important syntax is insert. So basically insert also works in the same way as MySQL. You have to insert into maybe let's assume nerd movies, nerd movies, nerd movies. Then you can add any movie you want. Maybe you can start by writing out different columns that you have created in the table called nerd movies. Maybe you created a column called movie director. You created a column called main actor, and the year it was released. Then you add values. I think you are familiar with this, where you insert into on nerd movies, then you add values. Maybe the movie is called Serenity, it's an example. Make sure you put quotes, single quotes, Serenity, and just maybe these guys, director, and so on and so forth. Then make sure after you are done, make sure you close out your statement with them. Yeah. Also, I'm sorry. Also, we can do update. We can do update in a very same way as MySQL as well. You just write update. Maybe we want to update our created table called nerd movies. Just write nerd movies. Then set the director, then set maybe you want to update the director is equal to Joss whoever, Joss maybe Whedon, Joss Whedon. You update the main character to the main actor, sorry. Maybe he's called Nathan. Then you add like the year it was released. Maybe it was released in 2000, right? And where, then you add where is equal to Serenity. So Serenity is now it's like you are trying to update nerd movies. We are trying to update like the movie nerd, like the table called nerd movies. Yeah, so basically that's how we do it. But the most important thing I think in Cassandra query language is what we call a batch statement. So batch statement, you can do all insert or update or delete statement at the same time. So maybe you write batch begin, then you write insert into users, user ID, it's an example, password, and so on. Then when you are done, you close it. You close it. Then you add another line, update users, set maybe password. When you are done, you close it as well. Then you add another line, maybe insert into table, into users, user ID and password. And then when you're done, you close it as well. You may also use delete statement, delete name from users where and so, and you close it. So when you are done, now you add another. When you are done, you close your statement with a parenthesis. Then then when you are done, now you can click enter to execute your statement. So basically, batch statement is the main statement you can put in your mind, because you can do delete, you can do insert, you can do update at the same time in Cassandra query language. So I didn't go through all of the syntax that I may need, but if you want to know more about those syntaxes, you can just Google out. Here are some documentation. You can see there is how to select, how to insert, how to update your table. You can see like my batch statement. You can see how to do data modeling. You can see how to do some arithmetic operations. So there are a lot of things you can do with these Cassandra query language documentation. Thank you so much, and all the best while learning these new non-SQL technology.